right, the correct IUPAC name for the following compound is. So we need to take a look at our compound and see what our functional groups are. And we can see that this molecule contains an alcohol and it contains an aldehyde. So we would need to know the priorities of our functional groups to know which is the higher priority functional group. And so we can see the functional group priorities in your textbook are in table 16.1. And when you look there, you will find out that the aldehyde here is your priority functional group. So that means that we're going to name this as an aldehyde and we're going to start numbering so that the aldehyde has the lowest possible number. So I am going to get the longest carbon chain that includes the aldehyde and gives it the lowest number. So it's definitely going to be number 1. And that's by default for aldehydes. So you actually don't even include that in the name. So 4, 5, 6, 7. So our parent chain is 7 carbon atoms and it's an aldehyde. So that is a heptanal. All right. And that "and" part there actually implies that it's an alkane. These are all carbon-carbon single bonds besides that aldehyde. Okay. And then as a substituent, we have our alcohol. And so when an alcohol is named as a parent chain, it's an all. As a substituent, this is a hydroxy group. So we have a 5-hydroxy. So we have 5-hydroxy heptanal. And then we also need to notice that this is a chiral carbon atom. And so let me draw in the 4th bond to the hydrogen. And hydrogen is always your lowest priority functional group. So it's really convenient that this is pointing away from us, which is where it needs to be by definition to assign RNS. So let me assign the priorities to the remaining groups so that oxygen would be the highest priority because you go oxygen, carbon, carbon. So between these two carbons, we can't differentiate yet. So we move out one more carbon atom. And here we end up with a methyl group. And then here we have a carbon that has more bonds to carbon. And we can actually draw in these comparisons so that if you're looking later on, you'll see how we did this. I just did it really fast. So the first thing I would do is compare these two carbon atoms, 4 and 6. And I see that they have the exact same 4 bonds. So that actually doesn't differentiate between this group and this group. So I'd have to go out to the next carbon atom. And I see 1 bond to carbon, 3 bonds to hydrogen here with the methyl group. And then I need to go to the next carbon and I see 2 bonds to carbon, 2 bonds to hydrogen. So, and I would keep going until I found a difference, no matter how far away from the chiral center it was. But fortunately, we didn't have to go too far this time to find this difference. And we see carbon versus hydrogen. So we're going to give a higher priority to this bond going down this way. And the priority group 4 is facing away from us. By definition, it needs to be in order to just directly assign the chirality. If we draw an arc going from 1 to 2 to 3, right? So counterclockwise, that's S. Clockwise would be R, but this is counterclockwise. So this is the S, 5-hydroxy heptanal. So that's option A.